Hello students. Today we will explore in detail about the topic of electrodeposition process. Today we will discuss in detail about the principle, process and application of electrodeposition process. I hope you all know about what is nano. So is nano means that is a particle which possessing a size of 1 billionth meter. That is 1 into 10 to the power minus 9 meter. So generally, nanochemistry deals with the various structure of matter having dimensions of the order of billions of matter. Whether it may be nanoparticles or nanomaterials, we can easily prepare by these two process, that is top-down process or bottom-up process. Generally, top-down process is a physical process, it is a hard method, and bottom-up process is a chemical method, that is a soft method process. So in the top-down process, the nanoparticles are prepared from the bulk materials. Here, the bulk materials are converted into smallest size particles. And whereas in the case of bottom-up process, here the smaller particles are converted into nanoparticles by combining atom by atoms or molecule by molecule or cluster into the nanoparticles. So electrodeposition is also the one among the bottom-up process. So let's discuss the electrodeposition process in detail. So electrodeposition is an electrochemical method. Here, the ions from the solution are deposited at the surface of cathode. It is also similar to that of normal electrodeposition process, but here we are using template-assisted electrodeposition in order to control the shape and size of the nanomaterials. Here, the specific arrangement can be prepared by this specific arrangement of nanoparticles can be prepared by this using this method using an active template as a cathode. So it is a template assisted electrodeposition process which is used to prepare the nanomaterials. So generally, electrochemical cell, that is this cell consists of a reference electrode and then one more anode and as well as template assisted cathode. So all these electrodes are connected through the battery through the voltmeter, and all the solutions, all these electrodes are dipped into a, so all this setup, that is a reference electrode, anode, as well as a cathode, all are dipped in the electrolytic solutions. Let's see one example, that is electrodeposition of gold particles on silver, that is a synthesis of nanostructured gold. Okay, so for the synthesis of nanostructured gold, we are using we are using gold sheet as an anode and cathode as a silver plate as a cathode. So here the alumina template is kept over the cathode and AuCl3 is used as an electrolyte. Okay. So for the preparation of gold particles, gold nanoparticles, gold anode is used and silver is used as a cathode, and in on the cathode the aluminum template is fixed in order to get the nano particles of gold. Okay, and here one reference electrode is attached. Generally, graphite is used as a reference electrode, and all the entire setup is connected through the battery, through the voltmeter, and then entire setup is immersed in a solution of iuryl chloride, AuCl3 solution. Okay, so it is employed as a electrolyte solution. So what happened is when the current of required strength is applied through the electrolyte, then the Au plus ion diffuses. Au plus ions diffuses into the pores of the aluminum plates and get reduced at the cathode as a gold particles. Okay, so if we keep on carry out this experiment, then automatically the portion is keep on increasing and we get an gold nanoparticles. So Electrodeposition is a technique that involves the reduction of metal ions at the cathode, resulting in the deposition of nanomaterials. So, this method offers us several advantages, including it is a very low, it is a cheap and fastest method, and also it control the um, control it has a very precise control over the synthesized process, and even complex shaped objects can also be coated, and we can get a thin film or a thin wire. um, uh, both both are obtained in a uniform manner, and also metal nanowires including nickel, cobalt, copper, and aluminum can also be fabricated by this method. Thank you for watching.